We have already studied the effects of force on a body in the previous class, haven't we? Students, now let us organize these to review the various effects of force. First, force and motion. Students, force changes the state of rest or motion of a body. Here is an activity to prove it. Keep a tennis ball on a table and push the ball slightly with your hand. What happens to the ball? The ball at once sets into motion, isn't it? Now, keep your hand on the opposite side of the moving ball. What happens then? The moving ball comes into a state of rest. This proves that the force changes the state of rest and even the motion of a body. Students, force can change the shape of an object. The change produced by a force on a body cannot be observed clearly. Look at this activity. Do you have an eraser? Take an eraser. Then, insert 2 nails, each of 1 inch, at the near ends of the eraser. What change do you observe in the eraser? You will observe both the ends of the eraser near the nails slightly increase. Similarly, when a spring is stretched holding it in between 2 hands, the shape of the spring will be changed. Students, force can change the direction of an object as well. To prove this, look at the activity. Do you have a toy car? Or a bus? Or even a motorcycle? Take a toy car, or a bus, or a motorbike, and tie a thread in the middle of one side of a spring around the car. Allow the toy car to move on the floor. It moves straight when it is in motion. Now, pull the spring towards you, as in the figure. Does the direction of motion of the car change? It does. Similarly, when a football player strikes the moving ball in another direction, the ball changes its direction.
Friction is a force that resists motion whenever 2 surfaces are in contact. When the friction is less, the objects slip past each other easily, and when the surfaces are rough, the objects does not move against each other easily. Example, you need friction between your shoes and ice to walk on it. You need friction between your hands and lid of the jar to open it. You need grip between your hands and handle of the bicycle to hold it firmly. You need friction between your shoes and paddles of the bicycle to paddle it. And you need no friction between you and the slide to enjoy the ride. You need no friction between the striker and the board to play. You need no friction between the balls due to the friction. Fine powders can also be used to make the surface smooth. Example, before playing carom board, we sprinkle talcum powder on the board to make the surface smooth. So kids, now you know what is friction and what are the advantages.
Vectors and scalars. Scalars, Physical quantities which can be completely specified by 1. A number which represents the magnitude of the quantity. 2. An appropriate unit are called scalars. Scalar quantities can be added, subtracted, multiplied, and divided by usual algebraic laws. Its examples include mass, distance, speed, density, volume, time, temperature, entropy, energy, charge, work, potential, etc. Vectors. Physical quantities which can be completely specified by 1. A number which represents the magnitude of the quantity. 2. An appropriate unit. 3. A specific direction are called vectors. This means a vector is a representation of both a quantity and a direction at the same time. Its examples includes displacement, force, velocity, acceleration, and momentum. Representation of a vector. A straight line parallel to the direction of the given vector is used to represent it. Length of the line on a certain scale specifies the magnitude of the vector. An arrowhead is put at one end of the line to indicate the direction of the given vector. Unit vector. A vector whose magnitude is 1 and directed along the direction of a given vector is called the unit vector of the given vector. A unit vector is usually denoted by a letter with a cap over it. For example, if r is the given vector, then r hat will be the unit vector in the direction of r, such that r equals r hat times norm of r, or r hat equals r divided by norm r. Unit vector equals vector divided by magnitude of the vector. Equal vectors. Two vectors having same directions, magnitude and unit are called equal vectors. Zero or null vector. A vector having zero magnitude and whose initial and terminal points are same is called a null vector. It is usually denoted by O. The difference of two equal vectors, same vector, is represented by a null vector. Free vector. A vector which can be displaced parallel to itself and applied at any point is known as a free vector. It can be specified by giving its magnitude and any two of the angles between the vector and the coordinate axis. In 3D, it is determined by the three projections on x, y, z axes. Position vector. Position vector is the vector which represents the position of a point in a space with respect to the origin, O. It also represents the distance and direction of the points from the origin. Resolution of a vector. Splitting up a single vector into its rectangular components is called the resolution of a vector. The rectangular components of a vector has to make an angle of 90 degrees with each other. There's another type of vector that you have seen but may not know about. Did you know all the graphics you are currently seeing in this animation are also called vectors? Vector graphics is a creation of digital images through a sequence of commands or mathematical statements that place lines and shapes in a given two-dimensional or three-dimensional space. The amazing thing about this graphic is no matter how many times you zoom into it, the quality will still be perfect and not pixelated.